All right, so today we're going to be talking about the squeeze theorem. That's what I call it. This author calls it the sandwich theorem. It's also called the pinch theorem. All of those things are synonymous with each other. But anyway, this is how a squeeze theorem works. If we need to find the limit as x approaches something of this middle one, we pick a function that's always going to be less than, and we pick something that's always going to be greater than. And we can get limits from those other ones. All right, we can get limits of the less than and limits of the greater than, and it's going to squeeze what we don't know about in the middle. All right, it's kind of like buns on a sandwich, or I think it just squeezes it. All right, so let's put that into practice. So here we go. Let's look at this example. So we're going to use the sandwich theorem or the squeeze theorem to evaluate this limit. Now, do I know g of x at all? Do I know it?
No.
I don't know this function at all. So, I do know the other two functions. You following me? So I know the function on the bottom and I know the function on top, and I can actually get to that limit. So, let's go over it again. Here we go. What's a limit? When you do what? Approach from both sides arbitrarily close to a number. All right, it gets you a y value number. That's what a limit is. Now, there are 4 reasons, and we'll discuss those later. So, I need to find a limit as x approaches -2 of g of x, whatever that is. So, I'm going to find a limit as x approaches -2 from the left. Now, when I do it from the left, what function am I actually using? If it's from the left, it is less than. So, I'm using this one. So I'm using the 5 minus 3x minus x squared. So now I'm just going to substitute in what? -2. That's what I try to do first every time. So if I substitute in -2, I get 5 and then what?
6.
Plus 6 and then minus 4. So 5 plus 6 is 11 minus 4. We end up with 7. All right. All right, so now I'm going to do a limit as x approaches 2, or -2, I'm sorry, from the right. So now, which one am I using? This x plus 9. So now I'm going to find the limit. So what do I get there? I get 7. So what do we know? If my limit from the left is 7 and my limit from the right is 7, what must be my limit of the middle one? 7. So now I know that the limit as x approaches -2 of g of x is equal to 7. All right, by the squeeze theorem or the sandwich theorem. All right, pretty cool?
Yeah.
All right, cool. All right, let's look at this next part. So now I have a limit as x approaches 0 of x squared cosine of 1 over x. What do we try to do first every single time? Substitute in. Well, I substitute in 0, I get 0, and then I get cosine of what? 1 over 0. Well, what's 1 over 0? Undefined. It's a vertical asymptote, right? So then I got a trig function of a vertical asymptote, and we talked about these before. What's a trig function of a vertical asymptote do? It oscillates. So I got to use the squeeze theorem here. All right? So what we do know is what's the minimum of a cosine value? -1, right? So the minimum of a cosine value is -1. And what's the maximum of a cosine value? 1. You following me? So the minimum that this function could be, if I say if this function is -1, that's the minimum, right?
Yeah.
So I'd have a negative x squared, which would be my minimum. And then I have x squared cosine of 1 over x. And then my maximum, this cosine function would go to what?
X squared.
1. So then it's 1 times x squared, which is just x squared. So now I have developed that inequality because I know the least a cosine could be is -1. The max a cosine could be is 1. You see how we did that? All right. So now I'm going to do a limit as x approaches 0 from the left. Well, which one am I using when it's from the left? The negative x squared. So now if I substitute in 0, I end up with what? I end up with 0. All right. And then I'm going to do a limit as x approaches 0 from the right. So which one am I using now? The x squared. And what do I get? 0. So now, what do I know my limit as x approaches 0 of x squared cosine of 1 over x is?
0.
That one's 0 because it got pinched right there. Does that make sense how we did that?
Yeah.
All right, cool. All right, let's keep moving. All right, so now we're on to be talking about limits involving infinity. And honestly, we've been doing this in Algebra 2 and Pre-Calc already. Now we just have a statement on it. All right, so let's talk about it. When I have a limit to infinity, it's really called like the end behavior. You follow me? It's what it does all the way at the right and all the way at the left. Remember doing this? All right. So if I look at this first function, I have 1 over x. Well, if I take a limit as x approaches infinity of 1 over x, I have a number over really big. Well, what do I get when I have a number over really big? It goes to what? It is a horizontal asymptote, that's true, but it goes to 0. All right. All right, let's look at this next one. So now if I have a limit as x approaches negative infinity of 1 over x, again, I have a number over a really big negative. So if I still have a number over a really big negative, that would also go to what? 0. All right. All right, let's look at part B now. So now if I have a limit as x approaches infinity of this 2x minus 1 over x plus 3, we're going to talk about this on the next page as well. But really, when I do a limit to infinity, I'm talking about horizontal asymptotes. What do we look at? The higher power. The higher power, right? And then they're the same on this one, true? So now we look at the coefficients. So what are my coefficients of my higher power? 2 and 1. So I end up with 2. So my limit to infinity will be 2 here. And then if we have to do a limit to x approaches negative infinity of this 2x minus 1, again, we're looking at the higher power, but now we have to worry about the signs. So now it's really a negative 2 over a negative 1, which is still what in this case? This is still 2. All right. So that is our end behavior or our limits to infinity and negative infinity.
So they're not always the same.
So anyway, we're basically finding horizontal asymptotes. Okay. So remember, if the degree of the numerator is larger, we don't have any horizontal asymptotes. So an example of that would be like an x to the 4th over x cubed. All right, the higher power is on top. It grows faster on top, so it goes to infinity or negative infinity, depending on which one you're going to. If the denominator is larger, you're going to have y equals 0. For instance, if you have like x cubed over x to the 4th, which one's bigger? The bottom one's bigger, right? So the bottom one grows faster, so the top doesn't matter. It just goes away, basically. So now that goes to y equals 0. And then if the degrees are the same, you get the coefficients. All right? So that one's kind of like a 3x cubed over a 4x cubed. Then what would be my asymptote here? Y equals 3/4. All right, you're looking at those coefficients on that one. All right, pretty good?
Yeah.
Remember that from before? Now we're just saying it's a limit to infinity. All right, this is the same thing. All right, so now let's put this into practice. So on this one, what am I concerned about?
Powers.
The powers. Where's my higher powers?
They're the same.
They're the samesies, all right? I don't care about all of these things right here. I care about these two right there. So, what's my limit to infinity? 3/5. That's how easy that is, all right? Pretty good? All right. So then let's look at B. So now I have 2x to the 5th on the biggest on top, and I have 3x squared as my biggest on the bottom. So what does that go to?
Nothing.
It goes to something. Do I have any vertical or horizontal asymptotes? No. But I actually am going to grow bigger on top, so it's going to go to infinity. Does that make sense? All right. Actually, I want to do another one like that. I think it will kind of help out. What if I have a limit as x approaches infinity of, let's say, negative 2x to the fifth over 3x squared? Then what would it go to? It would go to negative infinity because it actually takes its sign. All right. So what this means is this is the x value. This part right here is the x value. You following me? And then this, the limit, the answer is still the what? The y value. So this is meaning when I go to the right, it goes up. Does that make sense? This means as I go to the right, it goes down. Okay? All right. All right. All right, so on C, I'm looking for my higher powers. Well, they're equal. So what do I look at? The coefficient. So I look at these two right here. So what do I get? I get 2. All right, pretty good. All right. All right, let's look at part D now. I'm looking for my higher powers. Bottom's bigger. When bottom's bigger, what happens? It goes to 0. All right, pretty good. All right, let's keep moving. All right, so now we're looking for horizontal asymptotes. So it's basically just solving for our limits here. All right, so on part A, I have a limit to infinity. What's my limit to infinity of this one? It's 0. The higher power is on the bottom. So this one actually says find the horizontal asymptotes. So we just say y is equal to 0. That's all we're doing. Pretty good?
Yeah.
All right, cool. All right, on part B. All right, so on part B, I have a limit to infinity. What do we get? We get 2. All right, so what's my horizontal asymptote? Y equals 2. All right. Pretty good? All right. All right, this next part. Now I have a limit to what? Negative infinity. All right. So where's my higher power? The top. The top is my higher power. However, when I substitute a negative, what happens to it? What happens to it right here?
Oh, it comes positive.
It becomes positive, right? But what's going on my bottom? It stays negative. So what's my limit to negative infinity here? Negative infinity. My higher power is still up top. All right, so it's going to win. It's going to be infinity or negative infinity, but now we're going to have to talk about its sign. I want to go a little further on this one. That one, I didn't feel that great. So if I have a limit as x approaches negative infinity of, let's say, x to the fourth over 3x squared, what would that one be?
Positive.
That would be positive infinity. Why? Because both of them are even powers. All right, so the negative thing went away, so that would actually be positive infinity. All right, pretty good?
Yeah.
All right, cool. All right, limits involving infinity, numbers 1 and 3.